Alright, so this is question 1. Let's read this question. This is a quarter cylinder gate. Radius is 1 meter. Is hinged at the pivot point A. So this is the pivot point A. On top of the wall, which is separated by two fluids. So here, the left hand side, this is the one fluid and this is the other fluid, and which is the separated by the density. So the density of the first fluid, this is ρ1, and the second fluid, this is ρ2. Okay, so this is ρ1 and this is ρ2. So, and this is the wall. Okay, and this is shown here. This gate, it is 4 meter long. Okay, so this is 4 meter long. Alright, so now if you see here, the gate is 4 meter long in the direction into the face, and it is in the static equilibrium. You already know what actually static equilibrium means. So as it is separated by two fluids, so all the properties at the both sides, according to the theory, it should be same. We'll discuss that on later. So what we got so far, we have a quarter cylinder gate with this radius is 1 meter. It is hinged at the pivot A on the top of the wall. It separates two fluid, and the density ρ1 ρ2. Gate is 4 meter long. This is the free surface. Okay, and it is in the static equilibrium. The first question is, when the density is given like 1000 meter, we need to calculate the moment about A. So we need to calculate the moment by the force of the fluid 1 on the gate. So we need to calculate the moment about A. This is the first question. And the second question is, we need to calculate the density, okay, ρ2, when the density of the gate material is given 8000. So we need to calculate the density of this, and we need to calculate the moment about this A. So let's start with the first section, where we will now calculate the moment about A due to the force. So let's start with the solution now. So if you see the drawing here, it is actually something like this. If you already know the theories, so actually the force, the hydrostatic force on a curved surface, or hydrostatic force on the liquid surface, if you already know the theories, you're familiar with this term: center of pressure, centroid, the horizontal force, vertical force. Definitely I will upload on more videos for theories actually, and I will discuss what is center of pressure, what is centroid, and why we will get the horizontal force and the vertical force. So definitely, this is a lengthy problem, so I got less chance to discuss those theories here. It will increase the length of the video. So what I assume is, you know what is center of pressure, you know what is centroid, and you have enough idea about the horizontal and the vertical force for curved surface. So this is a the quarter cylinder. If you look here, so this is a curved surface, so, and this is the wall. If you see the question, so it is hinged at the pivot A on top of the wall, which is separated the two fluids. So this is the wall which separates the fluids. So let's say this point, this is actually the centroid, and this is the center of pressure, okay, P. So we define this is C, this is P, and this P, center of pressure, it is always just below of the centroid. If you go through the lecture slides, then you will get understanding why it is at the below of this surface. So the distance between the center and the center of pressure, it is this distance. We can say this is Cp, or delta Cp. So this distance between this centroid and this center of pressure. Okay, so we don't know this distance right now. We will calculate that on. we said the distance from the C to this open free surface. So this is, I told you, this symbol means this is the free surface. So this distance, we said this is L, and the distance from the center of pressure and this pivot point A, this is AB. Alright, this is the centroid of the area. We defined this all is A, B and D. So this quarter cylinder, we define this area is A, B, D. E is this point E, it is the centroid of the area. So according to the question, you see the length is given 4 meter. Okay, so the length is given 4 meter, and the radius of this quarter cylinder, this is 1. So eventually we can say AB or DB, this is equal the radius and it is equal 1. It is given in your question that the radius of this this quarter cylinder, this is 1. So now let's discuss how the horizontal and the vertical force act when it is the static equilibrium. So okay, let me show you this on it first. So when we got the radius is on, then closely look here guys, centroid means it is at the center of this. So if A and B it is equal 1, then we said the distance from C to B, we define this is L. So that means L it is equal AB over 2. So that's right here, L equal AB over 2 or R over 2. It is, that means half. Okay, so half of the radius, this is the L, the distance from this centroid to the free surface. Now if you see this arrow here, we said this horizontal force, it will act through the center of the pressure. I believe you know the theories and you know how it works. So now I'm assuming that you know this. So the horizontal force from this first fluid is acting through the center of the pressure, and similarly an equal amount of force for the second fluid will act from the opposite directions. You know Newton's second law, and it is in static equilibrium. So the Hayson, some amount of the horizontal force is acting through the center of the pressure, and the same amount of force is acting through this to keep the equilibrium. When it is the curved surface, we'll catch the vertical force. The vertical force is acting with this direction. So you see this V1. The vertical force is the force which actually acts due to its the weight. So the similar amount of force will apply through this downward direction through the centroid of the area ABD. This is the W. So W is the weight force which is acting to the centroid, and weight is actually the density, and the other body force acting here is the gravity. So the density, gravity, and the volume of the surface. So that's actually the weight force. Eventually this is the vertical force. So what I write here is, you see the fluid 1, that means the first fluid, the left hand side, whose density is rho1. So the fluid 1 exerts horizontal force Hayson through the center of the pressure. Okay, through the center of the pressure, it will always act through the center of the pressure of the plane area AB. So this is the plane area AB, this is the center of the pressure P. So Hayson, or the first fluid, it is exerts the horizontal force through the center of the pressure, that I wrote here clearly, and the vertical force V1 through the centroid of the area ABD, which is E. So the centroid of the area is E. So the vertical force is coming this way. So that's the horizontal and the vertical force. If you know, the first question is, we need to calculate the moment about it. So the moment is actually, we know the force. Okay, moment is the force, and let's say distance. Okay, distance. moment is equal to the force and the corresponding distance. So if you calculate the area here, so if you calculate the moment about A, so if your horizontal force is acting through this surface, so this is the corresponding area. Let's say the horizontal force is acting this way, so let's say this is h1, so it is acting this way, and this is your distance d. So the moment about this point, it is the horizontal force into the distance. Similarly, the vertical force and the distance. Okay, so let's say this is F, that means the horizontal force plus the force, vertical force, and the corresponding distance. Okay, and the corresponding distance. So this is just we'll discuss later on. So that means if we want to calculate the moment about A, this point, due to the force by fluid 1, that means this fluid. So this fluid is putting some horizontal force. We have vertical force as well because this is the curved surface. So if we want to get the moment about A, we need to calculate the horizontal force, the corresponding distance, the vertical force, and the corresponding distance. Okay, so that is our the final goal. We need the moment. And now I believe you're clear. If you want to get the moment, you need the horizontal force, vertical force, and the corresponding distance. Let's see. When it is the horizontal force, that means it is acting through this way, and this is the distance. This is the horizontal distance. Okay. When the vertical force is acting this way, this is the distance, x1. Okay, so if you can calculate this horizontal force, h1, and if you can calculate this vertical force v1, then you need to calculate the ap and this x1, then you will get the moment about A. This is the first part of discussion. Alright guys, I believe you got clear understanding. So the horizontal force, h1, this is actually the pressure and the area, how much pressure you're putting, and actually who is area. So when it is the fast fluid, the pressure, it is actually the rho 1 rho g height. So here height is the L, rho on gl. So when it is the height 1, this is the density rho 1, okay, gravity g, and the distance from the centroid, so this is the distance L, so rho on gl. And now what is the area? So area is, this is the surface. Okay, it is we are applying this, actually this is the horizontal force. So horizontal force, you already know, force always perpendicular to the surface. Okay, so perpendicular means it will create a 90-degree angle. So let's say this is the wall, so force is going this way, so it creates a 90-degree angle here. Okay, so it creates this 90-degree angle here. So now we need the area. So we know this radius and we know the length. Area means it is if you know the unit of the area, this is meter square, so that means it is the length. Okay, and the void. So here we know the radius, so the radius is AB and the length is 4. Okay, so this is actually the horizontal force. And now we had this point, center of pressure, and this is C, the centroid. So what is the distance, the CP? There is the formula, how we can calculate the distance. This is actually the formula of the distance CP. It is BD cube over 12 BDL. I actually do not have enough time to drive this formula. If you go through the books or your course notes, I'm not sure how it is available in your course note or not, but definitely you will get it from your books. What it is, let me explain. This is actually the length of the, when you will calculate the distance, the delta Cp or Cp, the distance of the centroid and center of pressure. It is actually the length. D, it is, the radius. and L is the length from the centroid up to the the free surface. So here B, if it B is the length, it is 4. Okay, D is the radius AB. 12 it is from the formula. B again length 4. D it is AB, and L we know L equal R by 2, the half of the radius. That means this is the half distance from the centroid, the center point. Okay, so if we simplify this, I believe I actually don't need to explain this. It will only increase the length of the video. So if we simplify this, then we will get the center of distance. It is AB over 6. Now we got that distance from the centroid. From the centroid and the center of pressure. We got the horizontal force. Now the vertical force. Vertical force is acting this way. It is actually due to the weight which is acting to the centroid. I said earlier, vertical force is actually it is the density, it is the gravity and the volume. This is the volume V. So here this is the the quarter circle. So let's go to the vertical distance. Is the vertical force V1. This is the vertical force is the density of the fluid and the gravity and the volume V. So volume V is the formula is 4 into the volume of that surface. So it is a quarter circle. So the area, it is pi r square area. This is the area into 4. So that means the 4 circle, we have only quarter circle. So if you see here, we have only this section. So this is pi ab square. So we have 3 more. So into 4, and so 4 is from the formula for the volume, and we'll divide for 4 because we are considering only this first quarter. So we just divide by 4. So eventually you can eliminate this term 4. So now the important thing is, guys, I don't know where it looks like this. It will be 4 and it will be 3. Okay, it will be 3. So we need the vertical distance. Look here, guys, this is the vertical force acting this way, and this is the distance. How you will calculate this distance, x1? I said the vertical distance is 4r over 3 pi. Let me just quickly show you this on here. I believe I got a picture for you. You see, this is for a semi circle or quarter cylinder. How you will calculate this distance? All the derivation you will get here. Actually, this you see this vertical distance y, it is 4r by 3 pi. So if you're interested, you can see this derivation here, or maybe your lecturer will explain this one actually, how to get this value. It is 4r or 3 pi. So I believe this is actually, it is not possible to track that one. So because you're solving, so I believe you know, and you have all the course note, everything there. So it is you will get it from there. So I can assume that you know this vertical distance x1, it is from the formula, it is 4r over 3 pi. So this is the vertical distance. So now previously we calculated this distance cp. If you can remember, we calculated this distance cp. Now we know this x1, but actually so far we know h1, we know v1, and we know the formula for x1. But when we will calculate the moment about a, we need this horizontal force. We know this, and we need this distance ap, but we don't know this distance. So ap, it is equal, you see, the AC, we definitely know AC, it is just half of this L, and we previously calculated CP. So if we write it down, AP equal AC minus CP, then AC, this is equal half of this distance, so this total distance is r, and if we take the value from here to here, this is r by 2. Okay, and cp equal, we did some calculation, so it is ab over 6. So this is ab over 6, and we know actually this is equal the radius r. Okay, so we can replace ab, it is equal r. Okay, so ab equal r, so we just substitute this value and we got it is equal r over 3 ap. So previously we know Hyson equal this, so now we know L equal AB by 2, so substitute this value. You see, L equal AB over 2, and now we know every value. The density ρ1 is 1000, gravity constant. We know AB equal 1, and this is force, so we got the horizontal force is this. Similarly, when it is the horizontal force, if we want to calculate the moment, I just said you that we need this distance AP, so we know AP equal R over 3, so this is 1 by 3. Similarly, we know the formula for the vertical force, we write it down earlier, this is the vertical force. So we just now substitute all the values here. Rho1 is 1000, gravity 9.8, AB equal 1, pi 3.1416. So we will get the vertical force is 30,820. Similarly, x, when we actually want to calculate the moment for vertical distance, is x1, and we know it is 4r by 3 pi, r equal 1 and pi equal 3.1416. So we substitute this. So now we know all distance, we know this horizontal force, we know this distance, we know this vertical force, and we know this distance. So the moment, it is moment about this point A, it is the horizontal force H on and this distance, and the vertical force V1 and this distance. And now if we do some calculations, then we got the moment is A1, 19,620. Okay, so this is for the force for the fluid A1, or the first fluid. Now similarly, when it is the second fluid, guys, look here, the second fluid will exert an equal amount of the force, the horizontal force, this way. Okay, so this will be H2 when it is the fluid, the second fluid, the density ρ2. So it will exert an equal amount of horizontal force through the center of the pressure. But here you can see we have no, the water surface, so we will not get any vertical force in this case, no vertical force acting this way. So let's calculate the horizontal force for fluid 2. So force by the fluid 2 on the gate due to H2. You see, we said H2 is the the horizontal force which is acting through the center of the pressure. So it will be same like the H2 equal this pressure, and this is the area we did for the first fluid. So when it is the pressure, only the difference is the density, and the area it will be same. That's all, and it is exactly same, only the density will be different. So see the first fluid, yeah, it is the horizontal force for the first fluid ρ1 GL and AB4. For second fluid, it is, you see, the ρ2 GL, only the difference is the density. So now that means if it is the only force, then the moment about A due to this horizontal force is this horizontal force plus, you see, this horizontal force, and then this distance from A, this distance, that means AB. So the moment about A due to H2 is, that means the horizontal force to the second fluid, it is M2 equal H2 into AP. But if it is the static equilibrium condition, guys, the question, if you can remember, it says it is in the static equilibrium. So the moment due to this first fluid and moment due to the second fluid, it will be equal. Okay, so that means if we actually want to do some the moment balance about this point A, so we already know the moment for A, so it will be the moment for first fluid M1, it will be equal to the moment for the second fluid M2. But if you see no, the vertical force is acting here and the other side, so if we actually want to do some balance, then we need to include this this vertical moment actually on this for the second fluid, otherwise we can't see the balance. So what we did here, we just included this term, this W, this weight. Okay, but this is the vertical force and this corresponding distance x. It is actually the weight of the gate, the weight it is acting through the centroid E of this area ABD. So now what will happen here, guys, it will give us some sort of balance of the moment about this point A. You can ask me, okay, why we already calculated the moment about A, this is the first part, so why you are doing this? You know, this is the horizontal force for the second fluid. We know everything, but we don't know this. If this is actually, we need to calculate, this is the second part of discussion, calculate the density, rho 2. So if we actually want to calculate this density, then what will happen here is we can't, because this is just an equation with unknown. This one is unknown and we don't know this haze too. So the only way is if we calculate the moment, we do some moment balance, then we already know the moment for this first fluid and we calculated this moment for this second fluid. So if we do this moment balance, we can calculate the weight and it will eventually give us the density. Let's see, I'll show you how. So the weight actually I showed you earlier, it is the moment is actually the mg, the sorry, I maybe previously I said this is the density, but it should be mass. So the mass, okay, the m, g, the gravity, and the volume. So the mass of the fluid and the gravity is the only body force acting here, and this is the volume, guys. The volume is why we divide it is we are only considering the first quarter of the circle. So that's why you see then the volume will be like this. So now substitute all the values, you will get the W, the weight. You already know this axon, the distance. You calculated somewhere here. The axon is 0.4244, the vertical distance. So once you know the weight, calculate the W in axon. This is this. So now you know this term and you know this term. And M2 we know, we just calculated earlier. The moment due to the horizontal force is rho 2 GL AB4 into AB. So this is the moment, you see, we calculated here. Haze 2 and AB. So haze 2 is rho 2 GL and AB into 4. So we substitute all these values here. So the only unknown is the rho 2. So now we will solve this expression for rho 2. Everything known, the moment aim on the AB is given the radius 1. So if we substitute all value, then we will get the density for the second fluid. So this is the density of the second fluid. So that's what we have done with this problem. So if you can remember what we did at the very beginning, let me do a quick review for you. What we did at the very beginning, we discussed actually the centroid, center of pressure, all of these lines. The horizontal force will exert through the center of the pressure and the corresponding distance. Vertical force will go through the centroid of the area and this corresponding vertical distance. So at first we calculated the horizontal force and the distance from the center of pressure and the centroid. Then we calculated the vertical force and the vertical distance. Then we did this calculations for AP. This is the horizontal distance, and now we substitute all the values for the horizontal force and the horizontal distance, vertical force, vertical distance. Then we calculated the moment. Moment is, it is very simple. So the moment is the, if you calculate the moment at this point, about this point, so the horizontal force corresponding horizontal distance, this horizontal force and this distance, and this vertical force and this corresponding distance. That's it. Similarly, when it is the second fluid, we calculated the second fluid will exert an equal amount of force, the horizontal force, through the center of the pressure. So we calculated the horizontal force, the moment, we did some moment balance, and now some simple calculation, and we got the density. So that's it, and definitely we'll discuss it during the the session. Okay, so that's all.